Hey guys, welcome. Yeah, so in this video, I'm going to show you a second way through which you can derive the formula for the inverse of a 2 by 2 matrix. And so let's title this and get started. The inverse of a 2 by 2 matrix. And I suppose we can have like a subtitle that says revisited, because we've already done this, but we did it through the adjoint and then multiplying the adjoint by 1 over the determinant. And here, we're just going to exploit the fact that for any square invertible matrix, A times A inverse will have to be the identity, right? And so since we're working with a 2 by 2 here, it'll be the identity for a 2 by 2. So what we're saying is that, like, if we have a certain 2 by 2 matrix with 4 entries A, B, C, D, A, B, C, D, then we can multiply it by its inverse, and let's say that the inverse right now just has entries W, X, Y, Z, and we know that the result will have to be the identity, which is 1, 0, 0, 1 for a 2 by 2, right? And what we're going to do is basically perform the matrix multiplication on the left side and then set the entries of the result to equal the entries of this, because that's what this equation says, and then use those relationships we create to solve for W, X, Y, and Z in terms of A, B, C, and D. Yeah? Okay, cool. So if we do the matrix multiplication, we know that we have to write 4 equations, the first of which will say that AW plus BY is equal to 1. And then another equation will say that AX plus BZ is equal to AX plus BZ is equal to 0, right? And then another one will say that CW plus DY is equal to 0. And then our final one will say CX plus DZ is equal to 1. And this is just matrix multiplication. That's how I got here. I got these 4 equations. And clearly we can use the 2 equations on the left, let's number them 1 and 2, to solve for W and Y. And that's exactly what I'm going to do. And then I'll leave it to you to use equations 3 and 4 here on the right to solve for X and Z. Yeah? Okay, cool. So to solve for W and Y, I'm going to start with this second equation here and write that it's the same as writing CW is equal to negative DY, which it surely is. And from that, we can say that Y is equal to CW divided by negative D. Okay, cool. And then I'm going to take this equivalent form for Y and replace Y there in the first equation with CW divided by negative D. And when I do, the first equation will turn into AW plus B, and then Y is CW divided by negative D, so I'll do that, equals 1. And now, if I factor out a W from the left side of this very last equation we wrote, I can write that I have W times, and it will be A, and then plus, it will be BC divided by negative D, and then equals 1, right? And it's pretty clear what I should do now, or what I should do next, which is multiply by negative D in the denominator here, but then that'll mean I'll have to do it in the numerator as well. Okay, so then this equation now is changed into W, and then times, and it will be negative AD, and then plus BC, all divided by negative D is equal to 1, right? Okay, cool. And so then next, it's pretty clear what I should do to solve for W, which is multiply both sides of this very last equation by the reciprocal of the quantity inside the parenthesis. And when I do, I can write that W is equal to negative D divided by minus AD plus BC. and then I can multiply both the numerator and the denominator of this expression by -1, and write that W is simply equal to D divided by AD minus BC. Now, I don't know if you recall our work when we got to the inverse of a 2 by 2 through the adjoint and multiplying the adjoint by 1 over the determinant, but this was exactly what we found this entry to be. Yeah? Okay, cool. So you see that this works, and now I guess I just have y left to solve for, and I'll be done. So since y is equal to CW minus D, and we just figured out what W is, right? It's clear that y is equal to C times W is what I just wrote down here. So that's D divided by AD minus BC. But then this just, now this right here just says CW, and I need to divide it by -D. And I'll write that is multiplying by -1 over D, and look at what happens. This D here and this D here take care of each other, and I've got that -1 right there multiplying the C. So I'll have that y is equal to -C divided by AD minus BC, but then multiplying both numerator and denominator here by -1, I could write that y is equal to C divided by BC minus AD, which again, if you recall to our earlier work on the 2 by 2 inverse, our other video, this was exactly what we found this entry to be, yeah? All right, cool. And then, you know, you could use these two equations, as I said, to solve for x and z in terms of a, b, c, and d, and you're done, and I'm done here.